So hello everyone, I'm Theo Lange and I'm a bachelor student at the Maastricht Science Programme. At the end of our third year, we have to do a bachelor thesis, research, and I decided to do it with the art conservation studio SRAL. So come with me, I'll show you what is inside. So during my time at MSP, I focused mainly into chemistry. And when I arrived in my third year, I could decide what I wanted to do my thesis on. And I therefore decided to join both my interest in art and my interest in chemistry. And here I came. This place is the art conservation studio. And what people do here is that they restore paintings in order for them to be in a state that is probably going to be able to last for hundreds of years. This allows the paintings to then be viewed by the next generations on and on. And in order to take decisions about the types of investigations that they have to take onto the objects, they have to understand the materials that have been used by the people creating these artworks. And that's where I come in. As a conservation scientist, I was able to investigate the types of materials present inside of the painting and give this information to the conservators for them to later on take decisions into the ways they want to preserve these paintings. So what did I have to do for my thesis? I came here and I had a meeting with Kate Seymour, Head of Education, and she told me that there was a possibility for me to analyze the ground layers of 5 Spanish panel paintings. These paintings have been produced in the 15th century, and all of them look pretty much like this. And there is, into these 5 paintings, 3 different sets. And these 3 different sets have been produced by different types of workshops in slightly different years across a similar area in Spain. By looking with analytical techniques, especially in the gesso layers, it allows us to have an understanding about the types of elements which are present in that layer. And by looking at the elements, I'm able to have understanding about the types of minerals which are present in these small parts of the painting. And by then looking per panel the types of elements and the types of potential minerals which are present in these panels, then I can do a comparison of these minerals and have an understanding of the original location of production of the panels. To sum up, the aim of my research was to look at the ground layers of panels which had been assumed to be constructed alongside each other. And by looking at the results and using these results to compare these 2 panels and see if there was actually large correlations in the construction techniques which had been used, and therefore be able to say that these panels had indeed been constructed alongside each other. The white part that you observe here is the ground layer. I also refer to it as the gesso layer. Since it is present in all the panels, its analysis allows for a good point of comparison. In order to understand more about these paintings, we take a tiny piece of the painting, and this allows us to then place these tiny pieces of paintings into resin cubes, and we are able to, using different experimental techniques, understand a lot about the materials which are present in the sample itself. And this is exactly what I have done. I collected 2 samples per panel. I had 5 panels, so I had 10 samples, and I looked at the mineral impurities that were found in the ground. Oh, well, I didn't see you there. Come, I'll show you the lab. So this is the SEM-EdX. This is the machine that I used in order to do my investigations of the samples. So the way this functions is that we take this sample and we place them inside the vacuum chamber, and in here we will bombard electrons onto the surface of these samples. The electrons will interact with the sample surface by creating different types of lights and different types of electrons. These will allow us to understand the topography or the morphology of the particles present in our sample. They will allow us to understand the types of elements which are present and the quantity of these elements present. Using this, we can then understand the elements, and by looking at the elements and the quantities, we're able to understand also potentially the types of minerals which are present. By using the SEM-EdX, I was able to collect 2 types of information. A first type, which is the backscatter electron images, which allows to view magnified pictures of the samples. And the second type, the characteristic X-ray graph, which allow to give an understanding of the types of elements which are present in the sample. To conclude, by using the backscatter electron images and by using the characteristic X-ray graphs, we were able to observe that between panels which had been assumed to have been constructed alongside each other, similarities in both the quantity and the types of elements present in the grounds was seen, and also that the construction of these grounds were similar. Consequently, it could be assumed that indeed these panels would have been constructed alongside each other. However, stronger types of analytical tools might be used in order to further enhance this assumption. When conducting a scientific research, certain types of ethical concerns may arise, and it is therefore important to state these ones. So in my case, I was investigating 15th century Spanish panels, and those were made available to me by a German museum. Since little is known about the history of acquisition of these paintings, the legitimacy has to be addressed. However, by being a scientist looking at the types of materials which are present in the panels, this allows us to better understand their history, but also very likely the region of production. And if this is then found, it is possible to acknowledge this region and also potentially the workshop with the artists which constructed these panels. So it is of interest for science to also have a look at these things. Thank you so much and see you next time.